Now, for those of you who were watching the last video and realized I made a mistake, excellent for you. If not, I apologize. When I simplify here, I was a little anxious and I forgot this over 2, this 1/2 here, so that still belongs there. And so this should be equal to 3 over 4. Whoops. I'm sorry, that's not it either. So this should be like so. It's quantity. Okay. X plus 3 over 2 squared. So this should be 3/2 x plus 3 over 2 quantity squared. And that means there should have been a 2 in here, in this part of the equation. Okay. So that's 5 plus 3, that's 8, divided by 2 is 4, squared. Let's cross off all of this. So this is 3 over 2. The result of this is just 4 squared. So this gives me 16. Gives me 3/2 times 16, which now reduces down to 24. So apologies for the mistake. Hopefully it didn't trip you up too much, but you can see where the mistake occurs. Okay. So with that in mind, now we are ready to move on to the next part of our learning of parametric equations. Now, in the last video, you saw me calculate the derivative dy dx at some time. Okay? And we want to find a general method of finding dy dx, and I should say in terms of t. So this is a little bit weird that we want to find the derivative with respect to dy dx, but we want to do it in terms of t, because we don't want to have to use t to calculate x, calculate y, and then plug it in. We just want to be able to plug t in right then and there. Okay? So there's a little bit of setup for this in order to do this derivation. So for starters, let's assume we have a parametric set of equations. X is in terms of t, x is some function f of t, y is some other function g of t. So for example, in the previous video, f of t would have been 2t minus 3, and g of t would have been t cubed. Okay? And then we can eliminate the parameter to get some new result. So let's say that we could eliminate the parameter to get y in terms of x, and we'll just call that function big F of x, okay, just to distinguish it from little f of t. So maybe I can show you here in the previous video, after I eliminate the parameter, I end up with this result. Okay, so this is y in terms of x. X plus 3 over 2 quantity cubed. This would be like, big F of x. Okay. And now comes the part where we start taking the derivative. Now, one thing that we can see here is that y is equal to g of t, and y is also equal to f of x. Therefore, we could set these equations equal to each other. So we can say that y is equal to g of t, okay, is equal to big F of x. And then we're going to take the derivative of both sides. So here we want to take derivative of both sides with respect to t.